Just imagine a civilization that has been around, developed its science and technology for 1 million years or for 1 billion years. Most stars form billions of years before the sun.
An alien object from beyond our solar system is hurtling toward Earth right now, and what scientists just discovered about it is completely unprecedented. This is 3I Atlas, the third confirmed interstellar visitor to breach our solar system. In less than 2 weeks, on December 19th, 2025, this comet will reach its closest approach to Earth at just 269 million kilometers away. That's 1.8 astronomical units, barely twice the distance between Earth and the sun. But here's what makes this critical. 4 separate space missions: NASA's Hubble Space Telescope, the European Space Agency's JUICE spacecraft, NASA's Stereo Solar Observatory, and the newly deployed Punch mission have all captured this object. And their findings reveal something deeply unusual about this ancient wanderer from interstellar space. Let's break down exactly what we're dealing with. 3I Atlas was first detected on July 1st, 2025. Within weeks, the Hubble Space Telescope, now in its 35th year of operation, locked onto the target. On its first observation in July, the comet was 365 million kilometers from Earth. The image showed a small, pixelated blue blob with the earliest signs of activity as it entered our solar system. Fast forward to November the 30th, 2025. Hubble captured new images when the comet was 286 million kilometers from Earth. The difference is shocking. The comet is significantly brighter. It had just passed perihelion, its closest point to the sun, 1 month earlier. Something changed, something activated. But Hubble wasn't alone in tracking this object. The European Space Agency's JUICE mission, currently en route to Jupiter, captured the comet on November 2nd and again on November 25th. JUICE was positioned 66 million kilometers from 3I Atlas, between the comet and the sun. This vantage point delivered unprecedented observations. JUICE didn't just see the coma, the fuzzy cometary atmosphere. It detected 2 distinct tails. The plasma tail, composed of charged particles pushed away from the sun in a straight trajectory, and then the dust tail, made of larger fragments of cometary material. But here's where it gets disturbing. The comet is exhibiting what scientists call an anti-tail, a tail pointing toward the sun, not away from it. This phenomenon is attributed to the size of particles being ejected by solar radiation hitting this ancient object. Investigators are struggling to explain the particle dynamics involved, and the coma itself shows unexplained irregularities. Recent scientific proposals suggest the interstellar interloper may possess active cryovolcanoes, volcanic vents spewing frozen material instead of molten rock. If confirmed, this would be the first interstellar object with active geological processes ever documented. NASA's Stereo mission, designed exclusively to study solar activity, wasn't even supposed to detect this comet. Analysts believe 3I Atlas would be too faint for Stereo's instruments, but using advanced image processing and stacking multiple exposures from the heliospheric Imager 1 instrument between September 11th and 25th, the comet was made visible. It appeared as a glowing anomaly in visible light data. Then came the photobomb. NASA's Punch mission was conducting the longest high-frequency observation of any comet in history, tracking Comet 2025R2 SWAN with images captured every few minutes between August and October. Most comets are observed once per day over extended periods, or multiple times per hour for short bursts. Punch shattered that record. And in the middle of that data, 3I Atlas appeared, moving in the opposite direction across the field of view. A cosmic intruder caught on camera during an unrelated investigation. Let's talk about what this really means. 3I Atlas is not from here. It didn't form in our solar system. It traveled through the cold darkness of interstellar space for potentially billions of years before entering our neighborhood. This object is a window into the conditions of star systems we may never reach. It carries chemical signatures, structural anomalies, and physical behaviors that predate the sun itself. The cryovolcanic activity, if real, suggests this comet isn't just a frozen rock. It has internal energy. It has processes happening beneath its surface. Processes we don't fully understand. the anti-tail behavior, the unusual brightness changes, the dual tail structure, these aren't just scientific curiosities. They're indicators that interstellar objects behave differently than solar system-born comets. Our models may not apply. Our predictions may be wrong. And here's the unsettling part. We've only identified 3 interstellar objects so far. 3I Atlas is one of them. The first was Oumuamua in 2017, an object so bizarre that some scientists proposed it could be an artificial probe. The second was 2I/Borisov in 2019. Now we have 3I, a TLAS. How many more are out there that we haven't detected? How many have passed through unnoticed? And what does their presence tell us about the density of rogue objects drifting between the stars? According to mission scientists at NASA and ESA, interstellar objects offer irreplaceable data about the galaxy's history. These are remnants of planetary formation events from distant star systems, some possibly extinct or collapsed. They carry isotopic ratios, volatile compositions, and mineral structures that reveal the conditions under which they formed. Investigators emphasize that 3I/ATLAS is much older than our solar system, which is approximately 4.6 billion years old. This comet could be a relic from the early Milky Way, billions of years before Earth existed. Analysts studying the JUICE data warn that the cryovolcanic hypothesis, while speculative, cannot be dismissed. If 3I/ATLAS is geologically active, it raises profound questions about how interstellar objects retain energy over cosmic timescales. Internal radioactive decay, tidal forces from previous stellar encounters, chemical reactions triggered by solar heating. The mechanisms are unclear. Officials at the European Space Agency note that JUICE's full data set isn't expected until February 2026 due to transmission limitations as the spacecraft continues toward Jupiter. What we're seeing now is only a fraction of the information collected. The team couldn't resist downloading a preview, just 1/4 of a single image from the November 2nd observation. That partial image alone revealed the dual tail structure and coma irregularities. What will the full data show? Here's the moment where the stakes explode. 3I Atlas will make its closest approach to Earth on December 19th, 2025. That's less than 2 weeks away. As the cosmic encounter accelerates, observatories across the globe and in space are preparing for a data blitz. Ground-based telescopes, space-based instruments, research teams coordinating simultaneous observations. This isn't just scientific curiosity. This is a race to capture as much information as possible before the comet moves beyond optimal observation range and disappears back into the interstellar void. Once it leaves, we may never see it again. We may never get another chance to study an active interstellar comet this closely. But here's what's escalating the urgency. The more we observe 3I Atlas, the more anomalies we find. The Hubble images show unexplained brightness changes. The JUICE images reveal structural features in the coma that don't match standard cometary models. The stereo data captures the comet in wavelengths that shouldn't make it visible at all, and the punch photobomb confirms it's moving through space in ways that challenge our tracking predictions. Every new image raises more questions than answers. Every observation suggests we're dealing with something fundamentally different from what we thought we understood about comets. And the cryovolcano theory, if that's confirmed, it means interstellar objects can remain geologically active across unimaginable spans of time and distance. It means the universe is stranger than we accounted for. It means the objects drifting between stars aren't just inert debris, they're dynamic, evolving systems. So what does this mean going forward? First, the immediate future. In the next 2 weeks, expect a flood of new images from observatories worldwide. NASA, ESA, amateur astronomers, university research teams, everyone with a telescope capable of resolving 3I ATLAS will be pointed at the sky. The data coming in will either confirm or demolish current theories about interstellar cometary behavior. Second, the long-term implications. 3I Atlas is a proof of concept. It proves we can detect, track, and study interstellar visitors if we have the right tools deployed. But it also proves we're currently blind to most of what's out there. Detection systems need upgrades. Observation networks need expansion. Early warning systems for close approaches need improvement. Third, the existential questions. If interstellar objects are this common, 3 confirmed in less than a decade, then the space between stars isn't empty. It's filled filled with rogue planets, ejected comets, ancient debris from dead solar systems, and possibly objects we can't even categorize yet. Some could pass closer than 3I, ATLAS. Some could pose collision risks. Some could carry materials or information that rewrite our understanding of the cosmos. Investigators are warning that 3I ATLAS is not an isolated case. It's a preview. As our detection technology improves, we will find more, many more. And each one will bring new mysteries, new anomalies, and new challenges to our models of how the universe works. Officials stress that while 3I Atlas poses no impact threat to Earth, its trajectory and behavior must be monitored continuously. Perturbations from Jupiter's gravity or the solar wind could alter its path in unpredictable ways. We need to understand these objects, not just for scientific curiosity, but for planetary defense preparedness. The truth is this: 3I Atlas is a messenger from a place and time we cannot visit. It carries secrets encoded in ice, rock, and volatile compounds formed under alien suns in regions of the galaxy we will likely never explore. Every observation, every data point, every image is a fragment of that message being decoded in real time. But the message isn't complete, and the clock is ticking. After December 19th, this interstellar visitor will begin its journey back into the abyss, fading from view, carrying its remaining secrets with it. The next 2 weeks will determine how much we learn and how much we lose. Subscribe for more updates as the truth continues to unfold.